In this video, we will go over properties of logarithms. Properties of logarithms allow us to change the form of logarithmic statements so that products can be converted into sums and vice versa. Quotients can be converted into differences and vice versa. And powers can be converted to products and vice versa. So in our first property is the product property. And we need to note that x, y, and a have to be greater than 0. They can't be negative and they can't equal 0. And a cannot be 1. And r has to be a real number. So the product property says the log base a of x times y can be rewritten as the log base a of x plus the log base a of y. So the sum of logs can be changed to the log of a product. The log of a product can be changed to the sum of logarithms. The next property is called the quotient property. Again, x, y, and a have to be greater than 0. A cannot equal 1, and r is a real number. So here we have the log base a of x divided by y. It's equivalent to the log base a of x minus the log base a of y. The difference of logarithms is equivalent to the logarithm of a quotient, and vice versa. The last property is called the power property. It allows us to take the exponent, the r, and change it so it's not an exponent anymore. And that can be very useful if r is our variable. It says the log base a of x to the r power is equal to r times the log base a of x. Now, because a to the 0 equals 1 and a to the first power equals a, if we take those exponential equations and rewrite them as logarithms, what we have are some additional properties. We have the log base a of 1 equals 0, and the log base a of a equals 1. So we can take the log base 6 of 7 times 9 and rewrite that using the product property, the log base 6 of 7 plus the log base 6 of 9. The log base 9 of 15 divided by 7 can be rewritten as a difference, the log base 9 of 15 minus the log base 9 of 7. The log base 5 of the square root of 8. We're going to actually use the power property on this, but first we have to change the root, the square root, to a fractional exponent. So now we have the log base 5 of 8 to the 1/2 power, and using the power property, that's equivalent to 1/2 times the log base 5 of 8. At this point, we don't care too much about the value of the log base 5 of 8. We're just practicing using our properties. The log base a of m times n times q divided by p to the second power t to the fourth power has a lot going on. First of all, we have the product property that we'll be able to use because we have several things being multiplied. We also have a quotient, so we'll be able to use the quotient property. And we also have the power property. We've got some exponents. So the first thing we're going to do is change this to a subtraction, and at the same time, change our multiplication, m times n times q, to an addition. So the log of m times n times q turns into the sum of these logarithms right here. But the division here, the quotient part, that's where the subtraction comes from. And we're subtracting the entire denominator. But the denominator is a product itself. So I'm subtracting the sum of these two logarithms. Now I keep going because I can simplify even more. This 2 I can bring out in the front using the power property. The 4 I can also bring out in the front using the power property. And now I can distribute my minus sign. And I end up with the log base a of m plus the log base a of n plus the log base a of q minus 2 log a of p minus 4 log base a of t. We're going to skip this example here. If you're interested, that's what it looks like. Also, we're going to skip this example here. This one's a lot more detailed. And we will also skip this example as well. In these examples, we're going to do the reverse direction. We're going to take multiple logarithms, sums and differences, and change them, rewrite them to a single logarithm. So we work with the first two. We're going to look at the log base 3 of x plus 2 plus the log base 3 of x, and we'll combine those two by multiplying them together, the log base 3 of x times x plus 2. But the subtraction now means we have to do some dividing. And that's why I have this quotient here divided by 2. So the final answer is the log base 3 of x plus 2 times x over 2. In this one, we have coefficients 2 and 3, 2 log base a of m minus 3 log base a of n. So the first thing we need to do is to bring the 2, the coefficient, up and make it an exponent, like we see over here. Bring the 3 up and make it an exponent. Now we have the minus here, so we're going to use the quotient property to put this back together as a quotient. So now we have a final answer of the log base a of m squared over n to the third power. The last example, we have coefficients that need to be turned into powers. We have sums that need to be turned into products. And we have a difference that we need to turn into a quotient. So the first thing we're going to do is move our 1/2 and our 3/2 up in an exponent spot. That's all we've done so far is change the 1/2 to the exponent and the 3/2 to the exponent. Now we start at the beginning. We notice this is a sum. So I'm going to combine those as a product. And the other one, if we go back, we see was being subtracted. And that subtraction tells me I'm going to change it into a quotient. So the final answer, the log base b of m to the 1/2 power times 2n to the 3/2 power all over m to the second times n. Now you could go further by noticing that you have m's and n's in the numerator and the denominator. So we'll write everything as plainly as we can. Notice that we have a 1/2 that we can subtract 2 from, the rules of exponents. That's a negative 3/2, and that's why down here we have m to the 3/2 in the bottom. Up here I would have an n to the 3/2, but I'm going to subtract an n to the first power, so 3/2 minus 1 gives me a positive 1/2. And this 2 to the 3/2 can't be combined with anything. So I would leave my answer like that.